Now, the one thing we know about inverses is that they have to be 1-to-1. Okay. Now, the 1-to-1 isn't bad for the tangent and cotangent because it's pretty much 1-to-1 if you pick just one interval. But with sine and cosine, it's repeating, so it'll never pass a horizontal line test. Okay, so what we're going to do there is we're not going to pick the entire graph. We're just going to pick from negative pi over 2 to pi over 2. Okay, because from there, it actually is monotonic. It's only going one direction. Okay, same thing for cosine. If you go from, say, 0 to pi, it's strictly decreasing. Okay. Same with cosecant. If you go from negative pi over 2 to pi over 2, let's say this is your negative pi over 2, and this is pi over 2. Okay, so this kind of repeats, so you know it's going to look something like that, and then that repeats over here. But if we go from negative pi over 2, strictly decreasing there, and it's strictly decreasing here. Okay, so it's actually strictly decreasing for both of those intervals. Okay, once you get past that, or before negative pi over 2, that's when it starts to change direction and you can't find the inverse. Okay, same thing with secant. If you go from 0 to pi, you notice from 0 to here, it's increasing. And from here to pi, it's increasing. Okay, so that's the only time we can use the inverse, so that's the only section we're going to really worry about. All right, so any questions on that one? All right. Okay, looks like everyone's done writing. Excuse me. Okay. Since inverse functions have to be monotonic, or 1-to-1, okay, so we're going to kind of have our functions, their domain, and then the inverse of that function, and the range. Thing is, the domain of the function becomes the range of the inverse. So they're really the exact same thing. Okay. So y equals sine of x. We're going to use the domain negative pi over 2 to pi over 2. Excuse me. Okay. The inverse, if we apply sine inverse to both sides, and remember the sine and sine inverse cancels out, we end up with sine inverse of y equals x. And remember, now you have the range of the inverse is just negative pi over 2 to pi over 2. Okay. Same thing with cosine. The cosine of x had a domain of 0 to pi. Okay. So we apply cosine inverse to both sides. cosine inverse of y equals x. And now that becomes the range. Okay. Same with tangent. Oh, quick side note, sine inverse is also called arcsine. Okay. Cosine inverse is also called arc cosine. Okay, so we have y equals tangent of x. Remember, that's from negative pi over 2 to pi over 2. And the inverse, same thing, tangent inverse of y equals x, where of course you have your arctangent. And again, that's from negative pi over 2 to pi over 2. Okay. Same with cosecant. But you remember that domain was negative pi over 2 to pi over 2. Okay. So now we have our cosecant inverse. Y equals x, which of course they sometimes call arc cosecant, where now that becomes the range, at least of the inverse. Okay, same with secant. Remember, that's from 0 to pi. So you end up with secant inverse equals x, or arcsecant. That's all one word. I don't know why I put a space there. Oh. Okay. And we have cotangent, which again is from 0 to pi. Okay, so you have cotangent inverse of y equals x, or arc cotangent. Okay, which is now the range of the inverse. Oops, slide that over. All right. So any questions on that one? All right, leave that up for a few. Okay, so now we'll put the formula for the derivative of the trig inverses. Oh, let's do it right. Oh, I'll leave that up for a few since a couple people are still writing. All right. Derivatives of inverse trig functions. Okay, so the derivative of sine inverse of x is equal to 1 over the square root of 1 minus x squared. Okay. Now, if you have, instead of, let's say, x, let's say you have some function of x. It could be x squared plus 3, 2x squared plus 7x plus 5, any function of x at all. Okay. Then that's going to equal 1 over the square root of 1 minus whatever that g of x is squared times the derivative of what's inside. Okay. Now cosine is the exact same, well, cosine inverse is the exact same as sine, with one difference. Yep, just negative. So if you remember sine, you remember cosine. Same thing with the function other than x. Exact same thing. 1 minus g of x squared times g prime of x, but it's negative. Okay, so we'll kind of separate those two, and we'll do tangent and cotangent. So derivative of tangent inverse of x is equal to 1 over 1 plus x squared. Okay. Now, if you had something other than x, if you had an actual function, a different function, then the inverse of tangent g of x will actually equal the same thing, 1 plus g of x squared times g prime of x. Okay, so cotangent is identical to tangent except negative. Cotangent inverse of x, just 1 over 1 plus x squared, but just make it negative. Same thing over here. Cotangent inverse. You have 1 over 1 plus g of x squared times g prime of x, but it's negative. Okay, so same thing with secant and cosecant. Well, secant inverse. Okay, so that's going to equal 1 over the absolute value of x times the square root of x squared minus 1. Okay, now if you had something other than x, secant inverse of some function g of x, then that's going to equal 1 over the absolute value of g of x times the square root of g of x squared minus 1 shorten that up just a hair times g prime of x. Straighten that up. There you go. Now cosecant is just the same thing but negative. Absolute value of x times square root of x squared minus 1. Why am I putting absolute value there? But make it negative. Okay, same thing here. Says cosecant inverse of some function g of x. Again, the exact same thing. So g of x squared minus 1 times g prime of x, but negative. Okay. So if you notice, all of the functions and their cofunctions are just the same but opposite sign. You have sine is positive, but cosine is negative. Tangent is positive, but cotangent is negative. Secant is positive, but cosecant is negative. So if you remember 3, you remember all of them. You don't have to remember all 6. All right. So any questions on that one? Okay. And I actually proved the sine inverse. You don't have to remember it or anything. It won't be on the test. But I'll just attach a copy of it in the notes if you want to look it over. All right, so let's do a couple of examples. Okay, so let's say, for example, if we wanted to determine r prime of x if r of x is equal to arc cosine of x to the 10th power. Okay, so you want to remember the derivative of cosine inverse, or arc cosine of x, is equal to -1 over the square root of 1 minus x squared. Okay. Now with this one, you'll just use the chain rule. Okay. So r prime of x is going to equal, you're going to bring that 10 down. Uh-oh. Forgot a C. Then subtract 1 times the derivative of what's inside. Okay, so this ends up being 10 times arc cosine of x to the 9th times -1 over the square root of 1 minus x squared. Okay. Which, if you wanted to simplify it a little more, it could just be -10 arc cosine of x to the 9th all over the square root of 1 minus x squared. All right, and that would be your answer. Uh-oh. So it really just goes down to remembering the formulas and plugging them in to the right spot. All right, so any questions on that one? All right. Okay, so let's do one more. Okay, so let's say if h of x is equal to x to the 9th arc cotangent of x, find h prime of x. Okay, so you want to remember that the derivative of arc cotangent of x is equal to -1 or 1 plus x squared. Okay, so our h prime of x is just going to equal, and since we have two different functions here, we have to use the product rule. Okay, so we have our first. Let me drop that down a little bit. So we have our first times the derivative of the second plus the second times the derivative of the first. Okay. Which just becomes x to the 9th times the derivative of arc cotangent, which is -1 over 1 plus x squared, plus arc cotangent times the derivative of x to the 9th, which is 9x to the 8th. Alright, so really it's not a whole lot you can do to that one except move that x to the 9th up top. So negative x to the 9th over 1 plus x squared plus 9x to the 8th, arc cotangent of x. Okay, so that would be your h prime of x. All right, so any questions on that one? All right, so we'll actually stop on that one. Okay, if you have any questions, like I said, feel free to hang